folks. I'm once again at one of my favorite places in the whole wide world, at the lathe. So I was getting ready to do another video, and I realized that my monthly meeting with the local Woodturners Club was right around the corner, and I hadn't done the President's Challenge yet. So I thought, maybe I can kill two birds with one stone. I can do a video on the President's Challenge for this month. Now, if you're not familiar with President's Challenges, a lot of woodturning clubs every month will have some kind of challenge put forward by the president. It could be a type of turning, maybe an ornament or a hollow form, or it could be a specific element that has to be in the turning, an undercut rim, maybe it needs to be lidded, or maybe a specific technique like multi-axis turning or inside-out turning. Now, what I really like about President's Challenges is that there's something for everybody. At one end of the spectrum, beginners, it's attainable to them, and maybe they get to do something that they hadn't thought about trying out before. And on the other end of the spectrum, it's open-ended enough for advanced turners to get creative. Now, what I always like to do with the President's Challenge is to try to find some maybe unorthodox way of approaching it, maybe some kind of unexpected way of creating the challenge, and maybe even pushing the definitions of the challenge. So this month, the challenge is to make a pair of candlestick holders in the style of Rude Osolnik. I hope I'm not butchering that name too badly. Now these are candlesticks that they're wide at the bottom and they thin out at the stem, and they widen out again at the top. So now I'm taking that to mean as long as it thins out and as long as it holds a candle, that counts as that style of candlestick. So the first thing that came to mind is maybe do some kind of multi-axis version of the candlesticks. But a lot of techniques are not going to be very kind to that thin spindle, and it's probably going to snap. So, and even if I get lucky enough to get through one of them, I got to get through at least two of them because I have to do a pair. So I start thinking about, are there any other kind of techniques? And then it occurs to me, this jig that I've been using for some time for making legs. I can do a whole set of 4 legs at one time, and it's essentially a multi-axis technique. And the way it works is you have 4 blanks mounted between these 2 jigs, and you work on one side of the turning at a time, and every time you finish that one side, you stop the lathe and you rotate each piece inside of the jig, and then you do the second side, or the third side, and fourth side, or however many sides you need to do to get the job done. So the more I thought about it, I think this is the perfect way to approach this. I got my multi-axis because this is just a form of multi-axis turning. I've got my multiple pieces. In fact, I'm going to do 4 all at once. And because I have more than one piece in the jig at the same time, those thinned out areas in the spindle are going to be able to withstand the forces a lot better than if there was just one. Now I'm going to have to warn you, because this is a new process for me, which means I'm going to be making a lot of mistakes, and I've left those right in there just to show that when you learn something new, mistakes are just a natural part of the process. And believe me, there's a couple of stupid ones in here. Alright, so time to get started. All I got to do is find a suitable chunk of wood.
So I head out to my storage shop to see what I have available. I find a nice piece of golden wattle, but I know that's a little bit too soft for this application. So I finally settle on a piece of pear wood. I want to get all 4 blanks out of this one piece of wood, so I'll cut it in half first with the miter saw. Then I'll rip the 2 halves in half on the table saw. The first thing I'll need to do is to prepare all the blanks for the jig. I don't need to completely rough out the blanks. I just need to get them small enough that they're smaller than the maximum size for the jig. And then I'll need to make 1-inch tendons on either end of the blank. I'm using a 3/4 inch skew to do my roughing. And I'm using a 3/8 bidan like a parting tool to do my 1-inch tendons. This 3/8 inch wide tool does a much faster job than my 1/8 inch parting tool. To size the tendons, I'm using a fixed 1-inch caliper, also known as a combination wrench. Every once in a while you'll see me throw my pinky up in the air. This isn't me trying to be hoity-toity. Sometimes the chips were going right towards my face and I was using my finger to deflect them. A quick check revealed that my tendon is still too large for the jig, so I got to take off a little bit more. And that does the trick, so on to the second blank. The second blank is more of the same, so let's take a closer look at the tools I'm using. The bidan I'm using is a shop-made tool that I made from a piece of 3/8" square high-speed steel. The bevel angle on this tool is about 40 degrees, and I like to use this tool the way the French do, with the bevel up. I chose to use a bidan here instead of a parting tool for two reasons. One, I don't have a parting tool this wide, and secondly, the bidan uses a similar tool rest height as the skew, so I don't have to keep changing the tool height back and forth. Here you can see the spring-loaded drive center that I started out using was giving me trouble when I was trying to recenter the blank, so I swapped it out for a more standard drive center. And on to the third blank. Seems like I'm really getting the hang of it after doing two, because looking at the times in the video, I did this third one in less than half the time as the first two. Perhaps that had to do with deciding to complete one end entirely before going on to the next one. And I get the tenon sizes just right on the first try this time. And on to the fourth and final blank. The skew I'm using here is my standard setup, which is a slightly radius skew with a skew angle of about 70 degrees and an included bevel angle of just under 40 degrees. I need the ends of the tenons to be square so that they register against the jig properly, and I find the easiest way to do that is at the miter saw. And this last blank seems to give me a little bit of trouble because I can't seem to find a position that feels safe. On one tenon I'll need to mark my different sides and then transfer these lines over to the side of the tenon so then I can use them to align them in the jig. I set out to do all four-sided candlesticks the way I'm marking this first one. But as I started marking the second one, I realized I'm not confined to making all four-sided candlesticks, so I go with 3 sides on the second blank instead. On the third blank, I decided to go with 4 sides again, but this time, instead of having all the angles 90 degrees, I just used some random supplementary angles, more of an X pattern. And on the final blank, I do another 3-sided candlestick, but this time I just picked the 3 sides at random. I have a pretty good idea how the first 3-sided symmetrical candlestick is going to look, but these last 2 candlesticks, I have no idea what they're going to end up looking like. And now I'm ready to mount all the blanks into the jig, or so I think. I can't seem to get the screw to take into this first blank, and then I discovered that it pretty much just stripped out, so I have to go find myself some longer screws. The longer screw seems to do the trick, but then I run into my second problem. When I try to put the second blank in, I realized I didn't calculate the maximum size of the blanks correctly. So that means I'm going to have to remount each blank and make it a little bit smaller. At this point, I don't want to lose any more material than I have to, so I take an accurate measurement on the jig for my maximum size. With the caliper set, I can make several grooves with the bidan at the right diameter, and then use a peeling cut with the skew to remove all the waste in between. So let's see if we can get these blanks mounted one more time. The second blank fits in next to the first, so that's a pretty good sign. You can't see it on camera here, but for each blank, I make sure that one of the pencil lines, any one of them, is lined up with a reference mark on the jig. Everything seems to be going well here, but at some point I discover that all these blanks need to be the exact same length for this jig to work. So I unmount all of the blanks and head back over to the miter saw, this time using a stop block to make sure all of the blanks are exactly the same length. And fortunately, I made sure I trimmed the tenon that did not have my pencil marks on them. so that I can still mount them in the jig correctly without having to redo all my marks. Things are going pretty good this time around, and it looks like I'll even be able to try to mount it between centers. A keyword here is try. I was having some trouble getting the jig to thread into the headstock and the tailstock because the two ends of the jigs were not quite parallel. Assuming one of my tenons was racked in the hole, I tried to give it a tap with a dead blow hammer on the lathe. That doesn't seem to work, so I got to pull the whole thing back off. And a good solid whack seems to seat the tenons correctly, but it also breaks my jig. Fortunately, the piece that breaks off is just a spacer and does not actually need to be glued on, so I just throw it onto the headstock. I'm finally actually ready to do some turning. Here I'm just making a couple of shoulder cuts on either side to mark the height of my candlesticks. That way all my candlesticks will be the same height. I mark my skinniest point of my candlesticks at about 2/3 up the candlesticks and make an initial parting cut at the skinniest part of my candlestick. I switch to a 1/2" spindle gouge to make what is essentially a large asymmetric cove. Even though I'm cutting quite a bit of air here, because the whole assembly is well balanced, I can really crank up the speed and you can barely notice that you're cutting any air at all. The cove doesn't look deep enough at this point, so I essentially repeat the whole process. And it always seems like the most difficult part of making a cove is fairing the bottom together nicely. And that's it for side 1. Now all I got to do is rotate 3 more times and do 3 more sides. Trying to take out just the 2 screws for the blank and rotating it didn't seem to work, so I pull off all the screws on one end to get it loose enough so that I can rotate that piece. The second piece is even more stubborn, so I have to resort to grabbing a pair of channel locks to rotate that one, being careful, of course, not to scar my reference lines. While rotating all of the blanks, I realized that I can leave one of my 3-sided blanks unrotated, and the original cove will show up as a shadow when I go to cut the second pass, and that way I can use that as a reference to duplicate the first cove exactly. With the second rotation spinning, you can see that shadow where the first cove was cut, and I'm simply cutting right up to that, just basically eliminating that shadow. On this second rotation, I rotate the 3-sided piece that I did not rotate last time, but do not rotate the 3-sided blank that I did rotate last time. That way I have another shadow that I can remove again. And the tenons seem to have loosened up a little bit from the last rotation. That way I don't have to resort to channel locks again. And once again, you can see the shadow that I'm going to cut away. But this time I try something a little bit different. I try to take away a bunch of the waste at the lowest point of the cove, and this seems to speed up the process a little bit. And for this third and final rotation, I rotate all of the blanks. For this fourth pass, I'm not relying so much on the shadow, but on the final looks of the candlesticks. And that whole idea of removing a bunch of the waste at the lowest point worked really well for me last time, so I stick with that.
At this point, I like the overall shape, but it doesn't thin out nearly enough in my opinion. That means I'm going to have to repeat the whole process to each of the 4 sides again. Fortunately, through the magic of video, this whole process only takes about 30 seconds. And that's more like it. I'm finished with the jig at this point, so I'll need to pull all the blanks out and finish them individually. Since all the turning went fairly smoothly and I haven't made a big mistake in a while, well, here comes a doozy. As I get ready to drill the candlestick holes, I noticed that the tenons at one end had a little dimple, and I figured this would be the side that was best to drill because the dimple would align it with the drill bit. But it wasn't until I finished drilling the third one that I realized I was drilling the hole in the wrong end of the candlestick. I decided that I don't need or want the tenons to be so long at this point, so I cut them back, leaving them just long enough that I can remark my centers. And then I remark my centers. As I go to drill a hole in the correct side this time, I think about perhaps not drilling the hole all the way, just far enough that I'll be able to finish it to final depth later on. Since I don't know how much I'll be dishing out the tops of the candlestick anyway, I wouldn't know exactly how deep to make the holes at this point anyway. To remount the blanks for final turning, on the drive center side, I use the dimple left by the Forstner bit to align a drive center, and in 3 cases, I use the 1/2-inch hole that I put in the wrong end of the candlestick against a cone live center. Although these candlesticks have to be sanded by hand because they're not round, I still find it easier to do that hand sanding while the blanks are mounted between centers. So I'll run through 150 grit, and then 220 grit, and finally 320 grit. You may also notice that I'm wiping down the work with blue cloth in between grits. That's just to make sure I don't have any leftover higher grit from the last piece of sandpaper. I don't sand past 320 at this point because I know at the end of my process I'll be buffing these, and that the buffing process can take out 320 scratches. I'll be dishing out the tops and the bottoms of the candlesticks, and even though I'm going against the grain and the tool complains a little bit, I don't worry too much at this point because I'm really just trying to remove material. As I get closer, I try scraping with the wing of the gouge, as well as trying a point tool, just trying to see what's going to give me my best results at this point. Then I remembered a tool I had made recently, for another President's Challenge, in fact, that might do a good job here if I could just remember where I put it. And this shop-made negative rake scraping tool seems to really do the trick. I stick with the gouge to remove most of the material, and then I switch back to my negative rake scraping tool to finish the surface. Since I'm using opposite sides of the scraping tool on either end of the work, I have to run back to the grinder each time to turn up the burr on the other side. And finally, to part off the piece, I used the gouge instead of a parting tool because being dished, the parting tool won't be able to get into that spot.
And my first candlestick is done. On to the second. The approach of using the gouge to remove the bulk of the material and then following up with my little scraping tool seems to work, so I go ahead and stick with that. In fact, you can see right here I'm getting some really nice shavings off of that tool. The remaining 3 candlesticks proceed more or less the same. Except that the 2 asymmetric pieces still seem a little bit fat in the middle to me, so I use the center axis to make one more pass with the cove shape, essentially adding one more axis. And now that the candlesticks are completely shaped, I can go ahead and finish drilling the hole for the candlesticks. Even though I'm using blue tape to mark the depth of the candlestick holes, I still check the wall thickness as I drill quite frequently to make sure I don't blow through the side of the candlestick. Having such a catastrophic event at this point in the project, so close to the finish line, would not be fun. The tops and bottoms need a little bit more sanding, and since it's kind of difficult to sand these by hand, I load up a sanding disc. The scraping tool left a pretty good finish, so I only need to go through 220 and 320 here. I want to make sure that these candlesticks sit nicely on a flat surface, so I lapped them with some sandpaper on my flat table saw. The first 3 only take a few swipes, but this last one seems to be a little stubborn. And there's one thing that never seems to get old, which is when that oil finish meets the wood. I'm using straight boiled linseed oil. I've used this on pearwood before and I find it works out really nicely. After a couple of days, the boiled linseed oil will have cured hard enough that I can take the candlesticks over to the buffer. Buffing leaves a nice satin finish that I like on this pearwood.
Alright, managed to get through and come out with a decent looking product for the President's Challenge. I probably next time want to make these a little bit taller and maybe make them even a little bit thinner around the spindle. But all in all, not too bad for a first time trying out a new technique. And even the mistake of the drilling mistake, you know, it's isolated to the bottom so you don't even really notice it too much. Now before I go, I just want to give sort of a general plug for wood turning clubs in general. Almost all areas of the country you should be able to find a local wood turning club. Now when I first started turning, I was kind of arrogant. I thought I didn't need to go to a club. I could just learn everything on the internet and just do it all in my own shop. And although the internet is a great resource for information, it's not quite the same as being able to meet with like-minded turners face to face. And you never know what you might learn at these clubs that you can't learn on the internet. Just as an example, this whole idea of chucking up several spindles and turning one side at a time, I had scoured the internet trying to describe the technique, seeing if anybody else was doing it, and I found nothing, so I was pretty sure that I had invented this technique. Well, at the last meeting when I was showing the candlesticks and showing the jig that I used to make it, we had in the audience our guest demonstrator for the night named Jim Rogers. After I showed off the candlesticks, he said, "Oh, by the way, did you know that's called therming?" Well, I had no idea. It turns out I'm not the inventor of this technique, and it's been around since the 1700s. Not only that, since now that I can Google the term therming, I found out there's a whole plethora of things that can be made with this technique besides table legs and candlesticks. So that's just one example of you never know what you might learn at these meetings. Alright, so that's all I have for this time, and until next time, stay safe at your own lathe. I'm Brian Havens, and thanks for watching.